So good morning students. So we are going to discuss about the next part of your controlled drug delivery system, that is your selection of drug candidate, or we can tell it is your physicochemical and biological properties of the drug for controlled drug delivery systems. The both will be same: selection of drug candidate, how to select a drug for a controlled drug delivery system, and also the physicochemical and biological property also will be same. Both are same, answer will be there. If the question will be, it may be different types, but answer will be same. So let us discuss about this, how to select a drug candidate for a particular controlled drug delivery system. So generally in the previously I told you uh, rationale of this controlled drug delivery system. This is also similar to this rationale and selection of the drug candidate. So in this, generally to optimize a formulation of controlled drug delivery system or to improve the performance of these formulations, we need release from the formulation properly. That means if the drug will not release properly from the formulation, then it won't work. That means it will not give uh, proper therapeutic effect, as concentration will not be maintained. And with this, there should be also proper movement of the drug within the body, so that it will give a proper pharmacokinetic parameters. So these are two properties required for the performance of the controlled drug delivery system. And with this, let us discuss about these properties. The first one, physiochemical properties that are affecting your controlled drug delivery systems. So first one, aqueous solubility, molecular weight of the drug, then your partition coefficient of the drug, drug pKa, and ionization at physiological pH, drug stability, then your biological factor like your absorption, metabolism, elimination half-life, dosage form index, pharmacodynamics factor like your therapeutic index. So now let us discuss about individually how they are affecting the drug candidate for the controlled drug delivery systems. The first one, aqueous solubility. Generally, if we know that the drug is good water soluble property, or it is a water soluble drug, then definitely it will dissolve very fastly and it will absorb very fastly. So this type of candidate generally suitable for the controlled drug delivery systems, and if the water solubility is less, or it is, we can tell, poor water solubility, then it will make a problem while release from the drug release from the controlled drug delivery system and to absorb properly. So that's why it should have a good water solubility, aqueous solubility for the design of controlled drug delivery system. Second one, molecular weight of the drug. So if molecular weight of the drug is less or low molecular weight drugs are there, then it is suitable for uh, controlled drug delivery system, because as we know that in the mechanism of absorption, generally 90% of the drug are absorbing through passive diffusion, and some other drugs are also transported through port transport and other mechanism also. But in all cases we can see, if molecular size is within the range below 600 daltons, then it can absorb well through the passive diffusion. If it is more than that 600 dalton, then it's very difficult process to absorb it. So that's why if molecular weight is less, then it is suitable for design of controlled drug delivery systems. Then coming to third one, partition coefficient of the drug. Partition coefficient means it is your both oil solubility and water solubility of the drugs. That means if you are choosing a drug which is having high partition coefficient, that will be suitable for candidate for your novel drug delivery systems or controlled drug delivery system, because High partition coefficient means it is having a good lipid solubility as well as it is having water solubility. So both the solubility is required, lipid solubility or oil solubility and water solubility also required for controlled drug delivery system, because water solubility for uh, dissolution in the dissolution media, stomach media, and lipid solubility for the absorption. So that's why if a drug is having good partition coefficient, then it will be suitable for controlled drug delivery systems. If it is having a low partition coefficient, then definitely that will be a problem for the absorption of drugs. The next one, drug pKa and ionization at physiological pH. So generally the pK range for the acidic drug for the ionization generally 3 to 7.5, and for the basic drug is 7 to 11. So generally this type of range 3 to 7.5 for acidic drugs and 7 to 11 for basic drugs are suitable for absorption, suitable for passive absorption. And if the drug is staying as non-ionized form, as I told you previously in the biopharmaceutics, if the drug will stay in non-ionized form, then it will be absorbed better as comparison to ionized form. Next one, drug stability. So drug stability means while we are discussing about stability of drugs, we are going for the dosage forms generally, but drug stability in the gastric environment is also affecting the its absorption pattern and its stability. So drug stability in the gastrointestinal tract also important, because some drugs are degraded in presence of acidic medium. So when you are taking the drug, it is going to the stomach in the acidic medium, and there itself it will be degraded, decomposed. So in these cases, we should not choose this type of drugs. If it is degraded in the stomach content or acidic medium, then we have to make a design to release it in the intestine. So generally, we should not choose this type of drugs. If drug is more stable in acidic medium, we need to choose this type of drugs for controlled drug delivery systems. Now coming to biological factor. Biological factor in this first one, absorption. So in this absorption, what will happen? Absorption means if the drug is absorbed very fastly, then it will maintain the minimum effective concentration very fastly, and it will give the therapeutic action. If the absorption is slow, then the slow absorbed drugs are not suitable for this controlled drug delivery system. Then it should absorb well to choose for controlled drug delivery system. Then coming to metabolism, some of the drugs they are metabolized. Generally metabolism means active form will change to inactive form. So some of the drugs they are fastly metabolized or rapidly metabolized. So in these cases also they are going fast pass metabolism. So in these cases we should not choose this type of drugs, because whenever we are choosing these will be degraded very fastly. For example, nitroglycerin in the intestinal tract, GI tract, this nitroglycerin will decompose or fast pass metabolized. So that's why we are not choosing this type of drugs, nitroglycerin. So that's why generally we are administering it in the buccal cavity to prevent this type of degradation and metabolism, fast pass metabolism. Then coming to third point, a biological factor, elimination half-life. So elimination half-life means also sometimes we are calling it as biological half-life. So it is an indication of all the parameters, pharmacokinetic parameters. It will show us the distribution, elimination, all the details we will get from this elimination half-life. So generally we are telling us T half. So if a drug is having very less half-life, like your less than 2 hours, then it is not suitable, because we need a high dose for that. If it is more than 6 hours, then also we should not choose it, because if it is more than 6, automatically it will stay more time in the body. automatically it will stay more time and will give a prolonged therapeutic effect inside the body. No need to go for controlled drug delivery system. So that's why for an optimized controlled drug delivery system, we need a half-life, biological half-life of 2 to 4 hours. 2 to 4 hours. Then your dosage form index. So dosage form index generally it is a maximum steady state concentration divided by minimum steady state concentration. So or we can write here CSS max divided by CSS minimum. So it is an index from which we can know how the drug is able to give better absorption, and we can optimize the dose of the controlled drug delivery systems. Generally, if it is 1, it is suitable for controlled drug delivery system. If it is 1. The next one, pharmacodynamic factor like therapeutic index. So therapeutic index already you know your LD50 by ED50. So therapeutic index generally, if this window is narrow, sometimes you can see some of the drugs are having narrow therapeutic index. That means it's very less. That means difference between the MSC and the MEC is very less. So what will happen? Immediately, if you take a slightly high dose, then it will give toxic effect, because there is a difference, very less gap between effective concentration and toxic concentration. So that's why if more concentration of drug is going to the blood, it will give immediately toxic concentration. So that's why we need to take a good therapeutic index drug so that it will not give the toxic effect. That means we should not take narrow therapeutic index drugs, it should be broad and there should be gap more between this toxic effect and effective concentration. So these are all your physicochemical and biological factors and pharmacodynamic factors and selection of drug candidate for controlled drug delivery system. So other things, classification of controlled drug delivery system, we will discuss in the next class. Thank you.